I'm trying something different than my recording here. I'm just recording in little 15-minute packages so I can email them or something later. It's a bit easier. I'm trying to do this for you guys so you can look back at this. But anyways, let's see how it goes. Minus, okay, let's say it is minus 5. Now, technically, that's a third term, okay? That's a third term, even though there's no variable. Now, I said with a variable in brackets, right? You can have constant terms because technically, this would be the same as saying x to the power of 0. Okay, now I don't want to get all too complicated on you, but this is another way you could write a constant term with x to the power of 0. So a constant term is okay. That's counted as a term, just a regular constant number. Yep, any regular number. Now, if you only had, if you didn't have any variables, if you didn't have a variable like x here, and you just had one number, okay, that's still a polynomial function, but it's just a horizontal line, straight line, but just horizontal line. It doesn't kind of go on an angle at all. I'm not sure what you mean by that. Right, these are different terms.
Yeah.
Yes, they're all different terms. So let me clarify one thing here, guys. Watch this. If I had this, okay, if I had this is not 3 separate terms, actually, because these are like terms. So really, what you would do is you would condense this down, you would gather all the like terms, okay? And then you would really only have one term in the end, right? So x plus x squared plus 2x squared minus 1x squared is just 2x squared. So yes, you could have, that's 3 terms. You could say, yeah, it's 3 terms. Well, yes, but when it's simplified, it's just down to 1 term. So really, we say that this has 3 terms in it because you could write each of these terms in an infinite number of ways. So we gather all the like terms before we say, hey, how many terms are there in this? Okay, so the degree of the function, though, is still the largest exponent on the variable. So this is a 1. If there's nothing shown, that's a 1. And this is a 2. So this is degree 2. And what shape of graph is degree 2? You remember? It's parabolic. It's this one right here. Okay? All right. So let's turn back to the book here and make sure that we're just learning kind of what's in 6.1. Okay, so there's a couple other things I need to talk to you about. They talk about cubic functions a lot, and they talk about end behavior and turning points. So let's talk about that. End behavior. So if we're talking about a graph and we're talking about end behavior, the end behavior is the description of the shape of the graph from left to right on the coordinate plane. So if we're talking about end behavior, we're talking about where the graph sort of starts on the left and ends on the right. And we describe it using the quadrants. So end behavior. All right, so I'm going to put it a little bit different than the textbook so that you have 2 things to compare. Okay? As the graph extends to the far left and the far right, which quadrants, okay, either 1, 2, 3, or 4, and I'll go over that too in a minute, which quadrants is the graph in? So it's only 2 quadrants that you pick, okay? And you pick only 2. So there's only 2 that you consider. Only 2 quadrants. And this would be very helpful if I just gave you a bunch of examples, okay? So here come your examples. Okay, so these are different coordinate planes here, and I'm going to draw you some graphs. A linear graph, okay, if this is a line that would extend forever in the left direction and forever in the right direction, this one's pretty easy to see, but To the far left now, if we go over here to this graph, and I look at the far left, it extends into which quadrant? And I mean, by quadrant, I mean which section of the coordinate plane. This quadrant right here. They are labeled quadrant 1. This is quadrant 1 over here. This is quadrant 2. This is quadrant 3. And this is quadrant 4. All right, so it's 1, 2, 3, 4 counterclockwise, starting at the top right. So the end behavior for this graph, okay, would be you would say starts in quadrant 1, starts in 3 because we'll go work from left to right. Starts in 3, ends in 1. I like to say starts and ends. You don't have to. You can say extends from 3 to 1. You can say extends from 1 to 3. You just have to name the right two quadrants. Okay? All right, here's another one. Here's a cubic function. Okay, that's the cubic shape. So which quadrants for this one? What are the two quadrants that they extend into? Quadrant 2, yeah, 2 to 4. So quadrant 2 to quadrant 4. All right. All right, so this one, which quadrants are we talking about? Remember, far left, far right. As this moves on, and you can probably envision that this is going to go that way, and this is going to go this way. So what quadrants are we talking about? Yeah, this one is 3 to 4. Over here, over here. Okay, here's a tricky one now. Okay, this is a parabola, but it's very skinny parabola. Okay, this is not straight up and down. It's a parabola. So you have to consider what would happen to the far left and the far right. Which quadrant? You can only pick two. Okay? All right, so if you look at the far left, obviously this one is going to go always, it's going to go forever in the upward direction, but it's also going to creep over to the left as well. You see that? It's going to creep up and left. This one is going to go up and also right. And if you talk about the, like as it moves, as x gets more positive, it's going to creep all the way over here, see? So yes, for this one it's 2, and it's going to end actually in 1 over here. Even though it looks like just this snapshot of the graph looks like it's not going to end in 1. Okay, so if we take a look at this, let me see, 1. Let's clear that. And if I did like, okay, 8x squared, and I'm going to, let's wait, 8. 8, okay, x minus 4 squared. What does that look like? Okay, check this one out. You see this? If you saw this on your calculator screen, really? If you saw this on your calculator screen, you might say, hey, both ends are in quadrant 1. But this is sort of what I'm saying about this example, is they actually keep going forever to the left and forever to the right, the parabolas. So this is actually 3 to 1. So that's what I'm talking about end behavior. I'm sorry. Yeah, over here. Yeah, 2. I pointed to 3 and said 2. I pointed to 2 and said 3. 2 to 1. Thank you. Okay, good? All right. Last thing we're going to talk about before you get to practice some questions here is turning points. Oops. Yes, hi. For 6.1, you know what? For 6.1, they do describe all of them. Oh, you mean later are we going to do more than cubic? I think, yeah, this, if you look on the next page, they show the linear and the quadratic and all that sort of stuff. We haven't really talked about constant function, but we did briefly. But I don't think you're going to see more than cubic, no, in this class, no. Okay, turning points. A turning point, folks, on page 381, it says a turning point is anywhere on the graph of a function where it changes from increasing to decreasing or vice versa. For example, this curve has two turning points since the y values change from decreasing to increasing and then to decreasing again. So, turning points. Okay. If you're looking at a graph and it goes like this, okay, let's say it looks something like that. That's not straight up and down, although it's a little confusing, but where it's dropping here. See, it's going negative. It's going negative, 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 and then it kind of comes to the bottom there, and then it turns around and goes the opposite direction, goes up. So this is a turning point. Okay, that is one turning point. This is another turning point because it's going positive or going increasing and then turn around to decreasing. Okay, got it? All right. Look at this this other example here, though. This one right here. This one doesn't have any turning points, actually. You've got 0 turning points because it is actually decreasing. It doesn't actually turn around to go up, ever. See that? It's decreasing everywhere, so there's no turning points here. No turning points. All right? Sorry? The difference? Well, see, this one's going down, right here, down, and then it goes up. So it turns around, goes down, then it turns around and goes up. This one's going down, but it never turns around. It still keeps going down. Got it? Okay. All right. Just to make it official, there's one other function, that's the constant function. Constant function. And that function is where you have no variables. It's y equals, and all of these are y equals, but there's no variable terms on this side. It's just like a constant value here. So that's why it's called a constant function. And they are always horizontal lines. Passing through y equals whatever this value is. X, I put it in quotes because whatever this is. So it's passing through y equals 3. So here's the y values here. And if we have y equals 3 right here, this function is a straight horizontal line passing through y equals 3. See that? Very, very easy. Okay? Okay, so what's this one right here? What's the equation for this constant function? Y equals 1, 2, 3, 4, 5, 6. -7. See, this is -7 right there. So that's y equals -7. Easy? Okay, I think that's all the teaching material for today. I'll give you your assignment coming up.